All right, I think this is recording. I will go over some of the problems here from the review for those of you who want it. So, let's look at a few problems. We will start with 15 and 16, which will kind of go together with 36 and 37. So, how do we solve something like 15, where x is trapped in the exponent? Well, students might not realize something like 5e to the power of x minus 3 equals 20. We can divide out this 5. That 5 is just a coefficient. So now I have e to the power of x minus 3 equals 4. And from here, we can rewrite. Anytime the variable is trapped in the exponent, we need to rewrite as a logarithm. That's how we get rid of the, or solve for x when it's trapped in the exponent. Since we see e, we take the natural log, base e, which is implied. You won't see that in the calculator. Of course, a logarithm solves for the exponent, which means we take the natural log of 4, which equals x minus 3. So, make sure this is in view. Again, and something students might not realize is that this is a value. The natural log of 4. We can just put that in the calculator. Here's the natural log button. Natural log of 4. Again, we're not going to see that base of e. It's implied. So the natural log of 4 is this value. And to get x by itself, all we need to do is add 3 to this value. And we can just do that in the calculator. So here's my previous answer. If I hit plus 3, the calculator will add 3 to the previous answer. So you don't need to write out this long number on paper or something. You can, but this is our answer. 4. I think it will tell you to round to 4 decimals, so 4.3863. So now, I'll look at 36. I'm having to record these differently, so I want to make sure that this is, like, you can see this. And then I'll do the rest of them. So, how long will it take $5,000 to grow to $12,000 if it is invested at 7.2% compounded continuously? And since we see the word continuously, this is our formula. And this pairs nicely with the previous problem because it says how long will it take, which means the variable we are solving for is t. So 12,000 is the A, that's the future amount. 5,000 is the principal, that's the amount we invested. And the rate, which will be part of the formula, is 0.072. We can't put the percentage in the formula. We have to put the decimal in the formula. So we move the decimal twice to the left. And so now, I'll put it down here, we have 12,000 equals 5,000 to the times e to the power of 0.072 times t. And again, this is a coefficient in front of the e. We can divide this out. And that's how you're going to work this problem. Well, that doesn't cancel, sorry. 12,000 divided by 5,000 is 2.4 equals e to the power of 0.072 t. So again, we divide out the coefficient on the right side here to get a value, but we'll just use the calculator to find that value, equals e to a power of 0.072 t. So again, if the variable is trapped in the exponent, we need to take the log. In this case, the natural log. A log solves for the exponent. So it's the natural log of 2.4. Again, the e is implied here, the base of e. So we will do the natural log of 2.4, which we can just put in the calculator. And we get, a value like this. And so all we need to do is divide by 0.072. Again, you don't need to take this number off to the side and write it down. This is the natural log of 2.4. T will be the natural log of 2.4 divided by 0.072. So I do divide by 0.072, divides the previous answer, and I can't remember what it will tell you to round to, but this is about 12 years, or 12.2 years, however it tells you to round. So, let's see if this recorded.